Hey guys, what's up? Going to film a little video to remind us how to solve problems like number 11 from the chapter 1 test. So, we've got this problem up here. It's negative 7x minus zy equals z plus 35. We're going to solve for y. Or sorry, not y, z. We could solve for whatever, but we could solve for the y or the z or the x. All we have to do is isolate it. So like you said already, John, we want this and this on the same side, obviously, because we want to isolate it. But what you had said for a moment is get all the variables on the same side. We only actually want those variable terms involving the z on one side and then everything else on the other side. So,
that's what I kind of meant was that.
Yeah, so I can either move this over here or move this over there. So which do you want to do? Either one's right.
Let's move the z plus 35. Let's move that z over to...
Let's move this z. So how do I move this z then?
I subtract z.
Subtract z. So we subtract z, but here's the issue. This z value and this z value are two totally different things. Because this is z times y and this is just z, I cannot combine these. These are not like terms, and that's where everybody keeps making their mistake. So with only doing that step, what I now have on the left side, negative 7x minus zy minus z equals 35. Now, in the same goal of me isolating my z, because I have z term, not a z term, I want to get this term on the other side of the equation. So how do I get this term to go to the other side of the equation?
You add it.
I add, yeah, right, because it's a negative term. I'm actually going to drag that highlighter, was really dark. So because it's a negative term, I'm going to add it, once I'm not stuck on my floor anymore. Oh, that's not red. Can I combine 7x with 35?
No.
No, those aren't like terms either. So I now get on the left side a negative zy minus z. My right side is 35 plus 7x. Now this is the point where everyone gets stuck. How do I get the z out of both of these? How can I pull out one common thing from two different terms? What's that process called? Do you remember? When I have to divide out one common value from two terms that are not like each other.
I don't know.
Factoring. So this is the and once I show you, you're gonna be like, oh yeah, this is the part that everyone's getting goofed off on. I want to get this z out of this term. I want to get this z out of this term, so I can divide by z and divide by z. But since I don't actually want to change anything, I just rewrite this with the z's factored out to the front. So now it becomes z times a negative y and a minus 1. Because remember, this is really negative 1 times z, and this was really negative y times z. So when I pull the z out, I now get z times negative y minus 1. Does this make sense, what we just did? The factoring process.
Mostly yes, but though with the z, why is there not multiple z's if you pull both out?
So when we factor, let's take another example. Like if I had two non-like terms, 3x plus 9. Can I add 3x and 9 together?
Cannot.
No, but they do share a common factor. This is a multiple of 3, and this is a multiple of 3. So I could pull the 3 out of both of them. So I could really say like divide by 3, divide by 3. But what that really does is it pulls the 3's to the front, if I'm going to show this as factoring. And then it says 3 times x plus 3. Because then if I go like forward through my process, my green's not right today, and I do this distribution,
Yes, the distributive property.
it will come back and be my 3x plus 9. So if I come back over here and I look at what would this be when I distribute, z times negative y would be negative zy. Z times negative 1 would be negative 1z. That's how we do that.
Yeah.
You got that now?
Yes.
Okay. What's up, Rodney?
What's happening, man? Is there a light switch for over here?
Yeah, they're over in the corner by the laptop cart, just hidden right back there. And then Matt said, make sure you turn in your timesheet today.
Okay. how do you do that? Like, what do you do?
You just write down whatever hours you've been here, total it up, and just turn it in.
Okay, what
We
about
just get
the-
63 per semester. So up to, I don't know, last week I didn't work as many hours as I'll work this week, so.
Right, okay, alright. So you just do it for the time you're here, nothing?
No, you can add in like whatever time you worked on the class. So even if you were home and working,
Yeah.
he just said whatever hours you put in.
Got it.
So yeah, we just get up to 63.
Per
All right.
semester, you said?
Yeah, per semester. So then we have one last step here, John, to get the Z actually by itself. Right now, what's going on with the Z?
It's being multiplied by negative y minus 1.
Yeah, and it doesn't even matter like what it's being multiplied by. We just see it's being multiplied by something. Get rid of that something. How do we do that?
Divide by negative y minus 1.
Uh-huh. We divide by that value on both sides.
Which means z equals 35 plus 7x over negative y minus 1.
Yeah, so it's messy, but that's fine. Z equals 35 plus 7x over negative y minus 1. That's what z would equal in that situation. So, problems similar to number 11 from that first chapter mastery. If you're still having issues with it, please come work with me. We might need to review your skills at factoring. So let me know if you're still having any struggles, but hopefully that helps.